Okay, so welcome back. We're going to be doing this problem today. But the problem statement is given an array nums containing unsorted distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. And so first step to tackle this problem is to understand what we are doing. So in the understand step, we want to understand what the inputs is. So the input is an array of, let's see, unsorted distinct numbers of n unsorted distinct numbers in the interval 0 to n. Okay, so we have examples of these inputs here. So 0, 1, 2 is an example of this, and 1, 0, 3, 4, and 0, 1, 2, 3, 4, 5, 9, 8 is an example. So all these integers here are in the interval 0 to 9, and we're going to be looking for the only number in the range that's missing from the array, and what's missing here is going to be 6. So that's an example of what the input is and outputs, and the outputs is going to be the missing number from the array. Okay, so we have examples here. So we can look at the examples up here. So we have examples if you have the interval 0, 1, 2, then we're considering the element that is 1 greater than 2 that's in this range. So that's going to be 3. And then if you have the interval 0, 1, 3, 4, then we see that we have a missing number from the range 0 to 3, which is 2. So we have the output is 2. And then over here we have the range is from 0 to 9. As you'll see pretty soon, we can count and find a missing number within this range. So 0, 1, 2, 3, 4, 5, and then 6. We don't have 6, 7, 8, 9. And so in the range 0 to 9, we have all the numbers except 6. So the missing number is 6. And then in this range, we have all the numbers from, it looks like 0 to 11. So we have, or 0 to 13 actually. So 0, 1, 2, 3, 4, 5, 6, 7. And then we don't have 8, 9, 10, 11, 12, 13. So the missing number is 8 in this case. So now that we have our set of examples of that help us understand what the input and outputs are, we can go on to the matching stage. So the matching stage, we can scout for similar problems. So similar problems are like factorial problems, where you have to search for a math property or math pattern to find optimal solution. And yeah, so what kinds of problems, so what kind of problem does this fall into in terms of the kinds of contents that we need to put into this problem? So we have loops, so do we need loops? So we need at least one, so we actually, at least one loop, depending on how you do it, we need at least one loop to iterate over all integers in interval 0 to n interval. And then we need selection statements, so selection. Not necessarily, but it just depends on type kind of solution you're looking for. So so the next step is to plan. So we're going to plan for an O(n) time complexity, an O(1) space complexity solution. So in this plan, you'll see how we'll go about finding the solution. So if we check out what the intervals are, so we have the interval 0 to n, and so we can consider all the numbers in this interval and ask ourselves if we are missing one. So if we're missing the ith so if we're missing the ith, so we have I minus 1 and I plus 1. So we're missing the ith element. Then how do we go about using these two intervals to our advantage to find a solution? So if you see a pattern, it's actually taking the summation, sum all integers in interval, and that summation is actually going to be there's a closed form solution to that. It's actually n times n plus 1 divided by 2. And we'll see, like, if you are missing one integer, then the summation of the interval with missing one, that integer, is going to be just made up by that particular integer. So the difference between these two intervals, or these two sets, is going to be that missing integer. So we could sum of this range of numbers missing I, and that equals, it's going to be n. So sum of all integers in interval minus missing number. Okay, so we have a good idea of how this actually works. So if you take, for example, 0, 1, 2, then we have the sum of, so we have the sum of this is equal to 3, and the sum of the interval 0, 1, 2, 3. So that's going to be, the entire interval is going to be 3, 4, 5, 6. And if we subtract 6 from 3, we get 3, and that's the missing number. So we can do this for any missing number in the interval, and we'll see that the solution is that the sum of the entire interval, or the total interval, minus the sum of the array integers, is going to be the missing number. Okay, so now we can, now that we understand the plan, we can implement the solution. So what we want to do is we want to define the total sum. So the total sum is going to be the length of integers times the length of integers plus 1 divided by 2, integer division. And then the sum, the array sum, is going to be the sum of the integers. And so we can return total sum minus array sum, and that will give us the answer. So we passed all tests. So you can see that this solution is indeed, what is it? O(n) time complexity and O(1) space complexity, since we don't use any space as constant space here. And we also have this sum on integers, and the sum on integers gives us an O(n) time complexity. And so that's the evaluation. So the evaluation is O(n) time complexity and O(1) space complexity. Okay, so we skipped a step, so let's go back to the review step so we can go to Python Tutor and visualize our solution. So we have the solution here, and so if we hit next, we're going to print this missing numbers function, and so we have the entire array of integers, and then we take the sum on the integers, and that's going to be saved as 16, and the total sum is saved as 21, and then we return the total sum minus array sum, which is 5, and so that's the answer. And the integers are 0, 1, 2, 2, 3, 4, 5, or 3, 4, 6. So it checks out so that 5 is the missing number from this integer array. Okay, so before we exit this program, we're going to talk a little bit about less optimal solutions. So just check it out. So we have this solution. This solution is O(n) time complexity and O(n) space complexity, and so it basically saves an integer of half scenes. So we basically initialize an integer array of length integers plus 1. So that's, we can check out to see which ones of integers already are half seen. So the first for loop goes through all the integers that half seen and mark half seen and integers, and we mark that with a 1. And then the second for loop goes through the entire half seen integer array and checks to see which one is 0, so it is not marked as half seen, and then we return that integer I. And so that's the O(n) and O(n) space complexity and time complexity solution. And we also have another solution here. This is O(n) log n time complexity and O(1) space complexity. And so it's O(n) log n because we have to sort the integers first. And after we sort the integers, we can just iterate along the integer line to find the one that's missing in that line. So we just return that line, and then if the integer array falls out, or the missing number falls outside of that range, then we just return the last the I plus 1 integer in that array. So that completes this solution sample of this programming exercise. So thanks for watching.